Part 4 of cardiac monitoring, we're going to discuss the ECG waveforms and intervals. So the objectives: identify the various waves and intervals of an ECG complex, including the P wave, the PR interval, the QRS complex, the ST segment, and the T wave. So to start out, let's just quickly review. If you've got a waveform that is above the isoelectric line, then that's a positive deflection. That means that the conduction is traveling towards that positive lead or that positive electrode. If you've got a waveform that is below the isoelectric line, that is a negative deflection, which means that the lead that you're viewing at that moment views that waveform as traveling away from it. And again, you've got your baseline, which is your isoelectric line, which is really the point of the beginning and the ending of all waves. So the electrical impulse leaves the SA node and produces a waveform on the graph paper. So the very first waveform that we're going to discuss is the P wave, which that is going to be the view of the atrial conduction. So when the conduction is delivered, it goes down the internodal pathways over to the Bachman's bundle to where all of the atria contract at the same time, and they create the P wave here. So the first wave produced by the electrical impulse from the SA node is the P wave. A normal looking P wave, a sinus P wave, this is going to be important. A sinus P wave should be smooth rounded, upwardly deflected, and it should look very similar to all the other P waves on the ECG printout. Now, a typical P wave is 0.10 seconds in length. Now, we don't actually measure the P wave. What we will measure is the PR interval. And the PR interval is essentially going to be the time impulse travels from the SA node through the internodal pathways in the atria towards the ventricles. Now, we've learned from early on that at the AV node, there is a physiological block of conduction everywhere except for at the AV node that allows the conduction to go through. But one of the things that the AV node does is it actually holds that conduction momentarily to allow for ventricular filling to finish, to allow for the atrial kick to occur. That way we can get that last little bit of blood down into the ventricles to give it that extension of the wall so that the Frank-Starling mechanism can come in. So again, the mechanical function and the electrical function, they work together, and they all have to work together, and these timing intervals are very, very important. So we will measure on the steps to rhythm interpretation the PR interval. So the PR interval actually starts at the point where the P wave starts, and it ends where you would see the Q wave. All right, and so a normal PR interval is 0.12 to 0.20 seconds. So for instance, this starts about on a solid line here, and we go about 4 small boxes, so that's going to give me 0.16, and then it ends in about the halfway point of another small box, so we'll add another 0.02 seconds. So you will end up having a PR for this one of 0.18 seconds. So again, the PR interval is going to be from the start of the P wave to the start of the Q wave, and that's going to tell us the time that it takes for the impulse to travel from the SA node through the internodal pathways and the time that the AV node actually holds up the conduction. So again, in normal circumstances, the PR interval should only be 0.12 to 0.20 seconds. The QRS complex. So we know the QRS complex as being representative of ventricular depolarization. So once the PR has completed, the first downward deflection, which usually will be very, very small, is going to be your Q wave. Then the first upward deflection is the R wave. And then the next downward deflection is the S wave. So we will actually measure the QRS complex because we want to know, is it wide or narrow? This is going to be important when we're interpreting rhythms in the future. But a normal QRS complex should be 0.12 seconds or less. So in this case, you've got a QRS complex where the Q wave actually starts about the middle. So it will be the same. It'll start at the same area that the PRI ended. So you've got a Q wave that starts about the middle right here, and then you've got a S wave that comes up and hits what we call the J point about the middle of that box right there. So together you've got one whole box, two whole boxes, and another half of a box, which will give you a QRS of about 0.10 seconds, which is normal. So it follows the rules. Then you have your ST segment. So your ST segment is actually just going to be a point in time in which it takes the ventricle to depolarize and to begin repolarizing, because your T wave represents ventricular repolarization. So you should see this meet back at the point of the isoelectric line. Now, the point in which it actually begins is called the J point, which is going to be this point right here. And then your T wave. So one of the things about a T wave is that it is a very dynamic wave. It is affected by different things. Electrolyte imbalances. It may be affected by acid base problems, things like that. But for a standard T wave, it should be an upright, smooth, rounded, slightly bigger than the P wave. But this is going to represent ventricular repolarization. This also is going to be where we're entering into our resting phase of our cardiac cycle, or ventricular repolarization. So, just a real quick summary. You've got your P wave. Your P wave should be smooth, rounded, upright, and it should be very similar to all the other P waves in order for it to be a sinus rhythm. You will identify the P wave, but then you will measure your PRI, which is going to be from the start of the P wave to the start of the Q wave, and it should be no more than 0.20 seconds and no less than 0.12 seconds. Then your QRS, the first downward deflection past the P wave, is going to be your Q wave. The next upward deflection is your R wave. The next downward deflection is your S wave, and it should come back and meet at the ST segment at the J point. We'll measure the QRS from the start of the Q wave to where the J point meets, and it should be less than 0.12 seconds. That determines whether it's wide or narrow. And then you've got your T wave. Now, we won't necessarily identify the T wave on our 5 basic steps that we're going to talk about soon, but it will be a very important player whenever we get into looking at ST elevation, depression, and identifying areas of MI. So it is very important for us to go ahead and have a good standard understanding, a very baseline understanding of what these waves represent and how to identify them on the ECG monitor. And that ends part 4 of the ECG monitoring lecture.